Welcome back, guys. Today I'm going to deal with a small topic that is fluid statics. In the fluid statics, there are mainly four subtopics we have to study. One is pressure, its properties. Second one, Pascal's law. Third one, Archimedes principle of thrust concept. Fourth one, acceleration of the fluid, static fluid. Acceleration of the static fluid. Next to fluid dynamics. So in this four, out of four, the Pascal law is only one application, means one model of the application, and Pascal law. So I have taken Pascal law now. So coming into Pascal law, so Pascal law states that the pressure at one point is equally distributed to all the points in the static fluid. Pressure at one point equally distributed to all the points. That means blowing the balloon, filling the balloon with water. Examples for Pascal means to understand the statement. It means that Pascal law is only valid for static fluid, means fluid at rest. So when fluid at rest, the pressure applied at this point on this area is equally distributed to this area in this to this point. That means here pressure is equal to here pressure. For example, these two punctures are not in horizontal line. So one is somewhat high. So then we have to take the difference between H rho Z. So that the model we will discuss later. In pressure, I'll explain that in pressure concept because H rho Z concept needed. So pressure is equal to thrust per end area. Thrust means force only, but is a perpendicular force. So perpendicular to area of cross section, how much force is acting. So that should be calculated. If force is not acting perpendicular to the cross section, so then P is equal to perpendicular component of force by area will come on that area. For example, this is one of the cross section, the force acting like this. So now this force is making some angle theta with or here like this. So then perpendicular component, you have to resolve this given force into perpendicular direction. Then your perpendicular component of force by area. That is F sin theta, cos theta depends on angle, right? So according to statement, P1 equal to P2 in this diagram. So now here, this Pascal law is more advantageous in our present life. That is hydraulic brakes, lifting the more luggages, lifting the by using the small effort, more weight you can lift. So unloading the luggages from the lorries, sand and stones from the tractor. So in olden days it will take lot of time and it will be involved with manpower. But now when lift came, so that become very easy. So there are many applications in Pascal daily life, very useful, and it is applicable only for fluid in the static state. So now see, the pressure at this on small area, this point is equal to E by A, and this point L by A. So now L by E is equal to capital A by small a. So this L by E, load by effort, is called mechanical advantage. So in some cases it will become as capital A by small a in Pascal law and wheel and axle case, capital A by small a. But in some other cases, screw jack and levers, in terms of levers there, load by means here effort arm by load arm. So load into load arm is equal to effort into effort arm. This is mechanical advantage in the levers. Effort arm means from the fixed point, how much distance effect is acting. Load arm means from the fixed point, means fulcrum. We'll call fulcrum, that is. So load where you are applying, where you are lifting. So that and the levers will study later. First order, second order, third order levers will study later. So now coming into the Pascal applications. So means mechanical advantage is there, lot of mechanical advantage, means by small effort. So here see, I can lift the load by applying the small effort, by multiplying the ratio of area. For example, I want to lift 1000 kgs, 1000 kg car. So the ratio of area is given 10. Then 100 kg effort apply means enough. Equal to 100 kg effort is enough. 100 into 10 is equal to. So there is a one simple trick, because it is not possible generally, but we'll tell this. So here one side there is a one big platform is there. So one side elephant is there, one side ant is there, small ant. So here big elephant is there, right? So now the ant can lift the elephant or not? It can balance or not? Yes, it can balance such that the load into load arm. This is load. This is called load arm. Which is equal to effort into effort arm. So effort, that means this mg. In equilibrium and rotatory mechanics will study this one, and here also it will be like in mechanical advantage. Means because of this platform, this is one mission mechanical advantage. So it is first starter mission. Possible, right? The mass into some distance is equal. For example, this is elephant is equal 10 tons, means 10 power 4 kg, and from this distance it is in 10 meters. So now ant is equal to 1 kg. So it move on this, means this much big platform move on this big platform x meters. Then it is possible, right? 10 power 5 meters. It is moving that much big platform is there, means is it possible to lift the, okay now, this one, right? So actually this will be down, this will be up, right? Actually this will be down and this will be up. I have taken diagram right now. So this is advantage of this formula, right? Pascal law. So coming into here in general applications. So here the question is given, the load 5000 kg of mass I want to lift. Otherwise sometimes they will give 5000 kg weight. So this is the weight of this vehicle or car, something bus, placed on the area of cross section 250 into 10 power 4, 10 power minus 4 meter square. So here very important, the load is given in kgs. Sometimes area they will give in centimeter square. You must convert into meter square. Otherwise wrong will come. If both areas involved means no need to convert, because the ratio only now we are going to find out in finding the effort or load. Both areas are given means no need to find out the convert into another unit, because the ratio get cancels. But otherwise compulsory need to convert into unit. That is also one point I have to remember. So now is asking only pressure. Pressure is equal to this much. Substituting mg. M means mg by area. Load kg weight is given means directly this is kg weight means mg only they have given. Substitute means you will get in kg weight is given me this is the answer, mass is given me this is the answer. So now coming into another model. So like above model, here 3000 kg mass is given, area is given, and here I want to tell one basic important for writing decimal values means in advance and in advance only they will ask decimals, two decimal points. In mains nearest integer they will ask, right? So in advance compulsory two decimal points you have to write. So this is very important point. So this is very easy problem. Mass is given, area is given, asking the pressure on the smaller piston is how much. This is a bigger piston, capital A is given. Smaller piston, how much pressure need to apply? How much pressure you need to apply? They are asking to lift this 3000 kg of a car. So this is very easy. mg by A apply means you are getting answer. But sometimes it will go wrong. Means you have done proper formula, you have used properly, and you got simplification also clearly 7.05 into 10 power 5. This is the answer. But in key, they will not give the 7.05, they will give 6.92 10 power 5 Pascal. Why means? So here G equal 10 you take means you will get 7.05. If it is not mentioned G is equal to 10 in question, it is taking too hard calculations also, you have to take 9.8 only. This is very important. So maximum cases the students will do mistake this. Actually, if 10 take means calculations will become easy and cancellation easy for us. That's why we will go with the 10. In maximum cases, they will give. If not given, and in integer type questions, compulsory people has to take 9.8 only, in that no doubt at all. So that is over the problem. So whereas coming into hydrostatic, next question, hydrostatic hydraulic press can lift the 1000 kg. Can lift the 100 kg, sorry. When mass m is placed on the smaller piston. So smaller piston of cross sectional area A you take, and big piston has means outlet capital A you take. So where on small piston small m mass I am keeping 100 kg I can lift, that equal to mg by A equal to 100 g by A according to Pascal law. Then m is equal to this much. This is the mass. So they will ask us mass sometime in some questions. So now they are changing the system now such that the diameter of the larger piston is increased by 4 times. See, increased by 4 times. Diameter is increased. Therefore, area is become 16 times. Capital area. And diameter of the smaller cylinder is decreased to 4 times. Decreased by 4 times. Therefore, it will become area will become small a by 16. So now ratio of capital A to small a is equal to increased to 256 times. Therefore, 100 into 250 times of mass I can lift. This is simple. But you are very thorough about this concept, then you go like this. Already in the first problem I have given load is equal to the ratio of area into effort. Very important. Okay. So how much load I can lift means the ratio of this one into effort. So here effort in this case is 100 kgs initially. Means mass is equal to 100 times into small a by capital A. Now this small a by capital A, the ratio is increased to 256 times, means capital A to small a. So now, when you can we see this problem. So now same mass we are placing on the smaller piston. So now the smaller piston is same mass mg and area is becoming a by 16, therefore 16 by a will come. That equal how much mass now I can lift. So mg by 16 into 16 times of a. Now small m is equal, I know already, 100 into small a by capital A, 16 by a. So here small in the small m place 1 is substituted here. This is the equation 2, this is the equation 1. 1 substituted here, you will get answer. So you understand, right? So this is 250 times 250 into 100 kgs. That much weight I can lift. So coming into another model. So there is a hydraulic chamber with a spring attached to the small piston, input piston. So sometimes they will go input and output, press puncture, pump puncture. So different to different question. But Pascal is same. F1 by A1 equal to F2 by A2. Pressure 1 is equal to pressure 2. Pressure at this smaller piston is equal to pressure at a larger piston at this point, right? So this is only the rule. So here there is a fluid. Here there is a fluid. So static fluid. Either it is gas or liquid. In hydraulic brakes and all, we are using the gas here, right? So now in the place of direct placing the mass, they have given spring. So now pressing the spring, it will compresses, right? Depends on the K value, it compresses. So spring constant, nature of the spring. K means stiffness of the spring, that equal to nature of the spring also given by K only. So now here effort is equal to Kx, then x equal to E by K. So he is giving the K value, small a value and capital A value and asking to find out X value. So same E by A is equal to 40 into G, 40 kg you want to lift. Then how much extension should happen in the spring they are asking. So they will give this much compression X value they will give and they will ask the K values how much or spring constant value how much. So here X is asking to find out from the given values I will get 5 into 10 power minus stop substituting. So this is about Pascal law and its application. So next topic I will explain in the next video. Thank you.